I think I got it. I got it.
Alright guys, so y'all are quiet. Can anybody tell me an observation about the graph? Okay, it's one line. It's a swoop. It's a swoop.
It crosses over the X.
No. That's actually the thing it doesn't do.
It goes to the line.
What, Libby? Why are you on the
What
phone?
do you want to add to the
I don't think she's paying attention.
Actually, yeah, we're talking about the observations of the graph.
Give us an observation.
I think that it'll swoop and not like
She already said that.
I really none
Let's hear a Korean characteristic. He came up with something. Talk to an actress. If no one else has it, do something brand new from you. About a graph.
about a graph or this graph.
This graph, but I mean, just put something out there maybe. After the conversation, I was in,
Doesn't wait. It's on the y-axis.
it does hit the line. Did somebody over here have something to add? Yes.
It's like a parabola.
It is. Colin says it's the shape of a parabola, but it's going the other way. That's absolutely right. It's not completely the shape of a parabola. It's a half parabola, but it is the exact congruent shape of a parabola. It's going sideways. Yeah. One thing I want to say that's kind of unique to this graph. We haven't seen a single graph like this so far. It has an end point and one arrow only. So I think all of our graphs have had an arrow going both ways. And this one specifically has an end point and arrow. There's something really unique about it there. So it sounds like several of us may have gotten stops. Oh, I was supposed to give you the clue to make a table. Did I not say that? No. Maybe you try making a table. Maybe that will help you to make a graph. What values should we try in the table?
0. Wait, 1.
-1.
Alright, now typically we do a table like this when we start a function out, right? I'm going to go ahead and let you know that this typical table does not work. Okay, so it's kind of, I know you would rather me just tell you the absolute right way first, but the wrong table kind of helps you understand the right table. So let's look at why this table would be considered wrong for this equation. What's the square root of -2?
There's not.
It's imaginary. You can't graph it. It's no good. That's a waste of a table value. You can't even graph an imaginary number. What's the square root of -1? I can't graph it. What a waste of space. What a waste of time. Square root of 0. Good. Square root of 1. Good. Square root of 2.
The square root.
All of a sudden I'm feeling like I don't like the square root of 2 either. It's 1.4. And I'm not a big fan of that. I don't want to graph 1.4. So of all these 5 values, there's really only 2 that I think is good. So let's look at the correct table. Let's do this the right way. Okay, I'm hearing good things. So 0 works. We can't do less than 0 because then we'll have imaginary numbers. So 0 is the lowest value that you can square root. So we're good with 0. 1 also works. So we're good with 1. I said I don't want to do 2. It's a decimal. Skip it. I don't even want to do 3. I don't want the square root of 3 either. Skip it. What about 4? 4 square root. So I like 4 for this table. Oh, I don't know the square root of 5. Hate it. I don't think I've ever wanted to mess with the square root of 6. 9. 9 works. I'm going to skip 5, 6, 7, 8, and I'm going to go all the way to 9. The square root of 9 is 3. And I'm just going to stop there. These are our 4 best values when you're writing a square root function. So as these get more complicated, our goal will be to have 0, 1, 4, and 9 as our radicands. Those are numbers that square root well. Radicands is the number underneath there, right? So anyway, go ahead and plot these points on your little graph. Again, it's page 439, and see what it looks like, and then consider domain and range. Go to 439 and graph it. What is it? The 9th. And it is a happy Friday. It's not a Christmas weekend. Don't let that get to you. It's still a good time.
Why did you, let me see, why those numbers? It's like 5, 1, 4, 9.
Because those numbers, like, they're all like, I have it memorized.
In the dark.
Like, don't like know the square root of 7 now. Or even 3. I don't even know that. I have to get a calculator. And it's decimal. So it's hardly apply that. Yeah, those are the formulas for the squares. Let me write that out. I was gonna write that
What's the range? No.
Okay, guys, I'm gonna find these numbers, 0, 1, 4, and 9. These are the 4 lowest perfect squares. That's why those are picked. These are the 4 lowest numbers that can square. From there, I would pick what? 16 and then 25, right? Those would give me a nice interval, but then that'd be a huge graph. Okay, let's draw it. I'm gonna go kind of off center here.
I went center.
No, it doesn't, but you'll find, particularly when we get to the assignment, that the little graph is not big enough. So if you have graph paper, with the way this graph goes, sometimes it's nice just to have a lot of space. So 0, 0, 1, 2, 3, 4. 1, 1, 4, 2, 9, 3. Alright, it's important that it looks a little bit curved. Should not be straight. It's defined as nonlinear. Should have a little wave to it. It's interesting, instead of most of our graphs we kind of see is going up, this appears to really go to the side. It is going up a little bit forever, but it really looks like it's going to the side. It is a parabola, reflected diagonally. What's wrong, what I will mark wrong, is if you have an arrow going this way. Because you can't square root negatives. The graph doesn't exist here. It has a dead end. Make sure you have an end point and an arrow. 2 arrows is wrong. It is possible to reflect this negative. So you can flip this way, in which time the arrow would go this way, but it would still just have an end point in the middle. So it's always an end point and an arrow. Okay. So domain, we haven't talked about in a long time, but it's x values. The x values start at 0 and go all the way to infinity. So we do a bracket to say this is the start, and that heads to infinity. And so since x can be negative for this graph, also y won't be negative. It'll always be positive. So the range is going to look similar. It goes from 0 to infinity. So the rest of class today will just be starting with this shape and moving it around, up, down, left, right, flipping it, just like we have done with other functions. Probably the most informative information for graphing is in this section. I think it's page 442. Let's try 442. You just read it. Look around. There's a nice table in this section that tells you all about transformations. Try to find it and hold the corner over so you know where it is. I was right. 442.
Cooper, what page is the?
442.
442. 442. If you end up graphing and you have decimals, it's okay. You can still make a graph with decimals.
I was just asking.
Alright, so on page 442, of all of the different graphs we've made with transformations, I think this is the clearest table that describes all of the different ways you can move a graph around. I highlighted reflection because that's going to be a tricky one, and we don't practice it very much. So go ahead, take a look and observe that if the negative sign is under the radical bar, that's going to flip it across the y-axis. So that's the case I just talked about, where it's going to actually point to the left. If there's a negative sign in front of x under there. Now, if the negative sign is out in front of the radical, that's what's going to make it flip down. So most of our functions we have flipped them down. This one can also flip left. We haven't done that before. So it starts like a regular little wavelength that way. You can flip it left or you can flip it down. And then horizontal stretches and shrinks are also tricky. We don't do any of those today, but I'll give you a strategy for those when we get there. Okay, so here are just a little bit of notes. If you like notes, here they are. Steps to graphing even root functions. So this is for square root, fourth root, sixth root, eighth root, whatever. You start with the parent function. This is the more basic way. Start with the parent function and identify transformation. So as a reminder, a number in front will cause a stretch, a shrink, or a reflection. So we're going to actually stretch that shape up and make it taller. We're going to smush it down and make it shorter. There's a number in the A spot. If there's a number under the radical bar, it'll become very important that you start to really look where's the radical bar end. That's going to shift the graph left or right. And then a number at the end will shift it up or down. Let's just phone. Next week we'll get into some more complicated, or whenever we do. If it's more complicated, you might want to try this strategy. You set the radicand equal to 0 and solve it, and that is where you'll start your table. So if there's like so many different numbers in there going on that you can't figure out how to move your graph around, you could try this. Take whatever's under the radical bar, set it equal to 0, solve it. That's how you'll make your table. Sometimes you're going to have to use decimals because you can't figure out what numbers will square root. And that's okay. If you have to use decimals, sometimes it's okay. You want to always consider creating perfect squares. Alright, I'm going to give you guys some time to write this down. You're going to start the assignment when you're ready. Just so you know, don't start with 11. Start with 13 or 14. They're the easiest. And I'll go through these with you.
We should write the beat code, right? Yeah. We should.
Question. Can you split decimals?
Yeah. Yeah, it's okay. It's just
You know the bottom. What did you say?
more decimals.